Okay, so these notes are going to be on powers of monomials. So it's called the power rule. Very similar to what we did yesterday, except notice now we have one variable with two exponents. So yesterday we had two variables and two exponents. So when you have one variable and two exponents, so basically an exponent with its own exponent, now you actually multiply these two exponents. So if I were going to rewrite this using the way that our formula chart writes it, x to the a, all of that to the b is the same thing as x to the a times b. If there is a coefficient, so let's say we had like a 2 in front of this, then we actually raise that coefficient to this power as well. So we'll do some examples like that in just a second. Okay, so let's just jump into the examples then here. So number one, and we have x squared, all of that to the fifth. So basically, again, we have a variable with an exponent, and then that exponent has an exponent. So one variable, two exponents, we multiply these. If I were writing that out in expanded form, basically I have x squared, sorry, my pen is not working very well today, x squared, let me try again. There we go, x squared times x squared. I have this 5 times, right? To the fifth means to write it 5 times. So 5 times, this is what I would have. Well, each x squared actually means x times x. So x times x, x times x, x times x, x times x. And now if I were going to rewrite all of this in simplified terms, I just see how many there are, and I can rewrite that. So I have 2, 4, 6, 8, 10. So I would rewrite this as x to the 10, which is the exact same thing if all I did was multiply 2 times 5. So 2 times 5 is 10. So this would be how you write it out in expanded form. And then when you simplify this to just exponent form, you get x to the 10. So again, we just multiply the 2 and the 5. So we have a variable, an exponent with its own exponent. So multiply those. All right, so number 2, now we have two variables, both with their own exponent, both of those with another exponent. So we have m to the 7, n to the 4, all of that to the 4th power. So we just multiply the exponents. So we would do m, I'll write it like this. So m to the 7 times 4, that's this 4 out here. And then we have n to the 4 times 4. So if we simplify that, then we get m to the 28, n to the 16. Because 7 times 4 is 28 and 4 times 4 is 16. The next one, so remember yesterday we talked about if we have a variable that doesn't have an exponent, it's an understood 1. So right here, I'm going to add in a 1. So this is going to be c to the 1 times 3, and then d squared times 3. So when we simplify that, c to the 1 times 3 would be c cubed, and d squared times 3 would be d to the 6th. Okay, so then examples with coefficients, very similar to yesterday, we actually raise the coefficient to the given power. So remember, the coefficient is the number attached to the variable, the big number basically. So this coefficient we're going to raise to the power, and then we simplify the variables with the power rule. So looking at the first example, we have 5x to the 7 squared. So again, if I'm writing that out in expanded form, sort of, I'm not going to do it all, it would look like this, 5x to the 7 times 5x to the 7. All right, which is kind of what we did yesterday, except now we would just do 5 times 5 is 25. X to the 7 times x to the 7, we add those, right? That would be x to the 14, right? That's what we learned yesterday, but not writing it out like this, if I just know 5 squared means 5 times 5 is 25, x to the 7 squared, I multiply these, 7 times 2 is 14. So this is what we did yesterday. This is now just kind of simplifying it back to this. All right, so I'm going to go down this row and then we'll do some more in class together. All right, so number 7, we have -4 c cubed d to the 4, all of that to the 4th power. So this is going to be really important. This -4, anytime you have a negative, you're definitely probably going to want to use your calculator. And then you have to put it in parentheses. So -4, we're going to raise to the 4th power. So I'm going to write out how I'm going to get this answer. So I'm going to do -4 to the 4th power. Then I would have c cubed times 4. That's this, again, this 4 out here. And then d to the 4th times 4. So -4 to the 4th power means -4 times -4 times -4 times -4. You do it 4 times. So you can do that in your, if you want, by yourself. I would personally use a calculator. So if I'm using my calculator here, I'm going to put parentheses, -4, close parentheses, use this little caret to the 4th power. So I get 256. I do want to show you, if I just do -4 to the 4th power without parentheses, it's going to tell me a negative. And that's because it just does 4 to the 4th power and then times -1. So please make sure you put it in parentheses every time. So that is positive 256. And then c cubed times 4, 3 times 4 would be 12. So c to the 12. And then d, 4 times 4 is 16. All right. So now number 10 is combining what we're learning right now today with what we learned yesterday. So this is an exponent, or a variable with an exponent with their own exponent. So this is the new rule. Then we multiply that times another monomial, which is the rule from yesterday. So if I'm doing this one, I'm going to do parentheses or exponent first. So these parentheses with this exponent, I want to do this first before multiplication. If I'm following PEMDAS, or order of operations, this comes first. So I'm going to do x cubed, right? This x cubed and then cubed again. So 3 times 3 is going to be to the 9th. And then y cubed, basically. 3 times 3, again, is 9. So y to the 9th. And now we're going to multiply that times x y squared. So remember the rule yesterday, when you're multiplying, now we're actually going to add these exponents. So this x to the 9 times this x is to the 1. So 9 plus 1 is going to be 10. So we would get x to the 10. And then y, we have 9 here and 2 here. We're multiplying these, but our rule is we actually add these two. So 9 plus 2 is 11. All right, so that is just a quick lesson on the power to a power rule.